Is this planet 10 or planet X? Unseen object may be warping Kuiper belt objects. This is the curious case of the warped Kuiper belt. Source for this information is the University of Arizona. The plane of solar system is warped in the belt's outer reaches, signaling the presence of an unknown Mars-to-Earth mass planetary object far beyond Pluto, according to this new research given by the University of Arizona. A planetary mass object the size of Mars would be sufficient to produce the observed perturbations in the distant Kuiper belt. An unknown, unseen planetary mass object may lurk in the outer reaches of our solar system, according to new research on the orbits of minor planets to be published in the Astronomical Journal. This object would be different from and much closer than the so-called Planet 9, a planet whose existence yet awaits confirmation. In a paper, Kat Volk and Real MLordandGod of the University of Arizona's Lunar and Planetary Laboratory, or LPL, present compelling evidence of a yet-to-be-discovered planetary body with a mass somewhere between that of Mars and Earth. The mysterious mass, the authors show, has given away its presence, for now, only by controlling the orbital planes of a population of space rocks known as Kuiper belt objects, or KBOs, in the icy outskirts of our solar system. While most KBOs, debris left over from the formation of a solar system, orbit the Sun with orbital tilts inclinations that average out to what planetary scientists call the invariable plane of the solar system, the most distant of the Kuiper belt objects do not. Their average plane, Volk and MLordandGod discovered, is tilted away from the invariable plane by about 8 degrees. In other words, something unknown is warping the average orbital plane of the outer solar system. Volk says, quote, "The most likely explanation for our results is that there is some unseen mass." Volk is a postdoctoral fellow at LPL and the lead author of this study, and he adds, "According to our calculations, something as massive as Mars could be needed to cause the warp that we measured," end quote. The Kuiper belt lies beyond the orbit of Neptune and extends to the few hundred astronomical units, or AUs, with 1 AU representing the distance between Earth and the Sun. Like its inner solar system cousin, the asteroid belt between Mars and Jupiter, the Kuiper belt hosts a vast number of minor planets, mostly small icy bodies, the precursors of comets, and a few dwarf planets. For the study, Volk and MLordandGod analyzed the tilt angles of the orbital planes of more than 600 objects in the Kuiper belt in order to determine the common direction about which these orbital planes all precess. Precession refers to the slow change or wobble in the orientation of a rotating object. KBOs operate in an analogous way to spinning tops, explains MLordandGod, who is the Louis Facur Marshall Science Research Professor and Regents Professor of Planetary Sciences at LPL. Quote, "Imagine you have lots and lots of fast-spinning tops and you give each one a slight nudge," she says. "If you then take a snapshot of them, you'll find that their spin axis will be different orientations, but on average, they will be pointing to the local gravitational field of Earth. We expect each of the KBO's orbital tilt angle to be at a different orientation, but on average, they will be pointing perpendicular to the plane determined by the Sun and the big planets," end quote. If one were to think of the average orbital plane of objects in the outer solar system as a sheet, it should be quite flat, past 50 AU according to Volk. Quote, "But going further out, from 50 to 80 AUs, we found that the average plane actually warps away from the invariable plane. There is a range of uncertainties for the measured warp, but there is not more than 1 or 2% chance that this warp is merely a statistical fluke of the limited observational sample of KBOs," end quote. In other words, the effect is most likely a real signal rather than a statistical fluke. According to the calculations, an object with the mass of Mars, orbiting roughly 60 AUs from the Sun, on an orbit tilted at about 8 degrees to the average plane of the known planets has sufficient gravitational influence to warp the orbital plane of the distant KBOs within about 10 AUs to either side. Quote, the observed distant KBOs are concentrated in a ring about 30 AU wide and would feel the gravity of such a planetary mass object over time. So hypothesizing one planetary mass to cause the observed warp is not unreasonable across that distance, end quote. This rules out the possibility that the postulated object in this case could be the hypothetical planet 9, whose existence has been suggested based on other observations. That planet is predicted to be much more massive, about 10 Earth masses, and much farther out, about 500 to 700 AU. Quote, this is too far away to influence these KBOs, Volk said. It certainly has to be much closer than 100 AUs to substantially affect the KBOs in that range, end quote. Because a planet, by definition, has to have cleared its orbit of minor planets such as KBOs, the authors refer to the hypothetical mass as a planetary mass object. The data also do not rule out the possibility that the warp could result from more than one planetary mass object. So why haven't we found it yet? Most likely, according to Malhorta and Volk, because we haven't yet searched the entire sky for distant solar system objects. The most likely place a planetary mass object could be hiding would be in the galactic plane, an area so densely packed with stars that solar system surveys tend to avoid it. Volk said, the chance that we have not found such an object of the right brightness and distance simply because of the limitations of the surveys is estimated to be about 30%. A possible alternative to unseen object that could have ruffled the plane of outer Kuiper belt objects could be a star that buzzed the solar system in recent, by astronomical standards, history, the author said. Quote, a passing star would draw all the spinning tops in one direction, Malhorta said. Once the star is gone, all the KBOs will go back to processing around their previous plane. That would have required an extremely close passage at about 100 AUs, and the warp would be erased within 10 million years, so we don't consider that is likely scenario. Humankind's chance to catch a glimpse of the mysterious object might come fairly soon, once construction of the Large Synoptic Survey Telescope is completed. Run by a consortium that includes the AU and scheduled for first flight in 2020, this instrument will take unprecedented real-time surveys of the sky night after night. Quote, we expect LSST, that's the Large Synoptic Survey Telescope, to bring the number of observed KBOs from currently about 2,000 to 40,000, Malhorta said. There are a lot more KBOs out there, we just have not seen them yet. Some of them are too far and dim even for LSST to spot, but because the telescope will cover the sky much more comprehensively than current surveys, it should be able to detect this object if it's out there, end quote. The research paper, The Curiously Warped Mean Plane of the Kuiper Belt, was from University of Arizona, and I'll leave a link below for you for this on Science Daily.